With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
In the diagram shown, find the potential difference between the points A and B and between the points B and C in the steady state. So the points A and B are here, B, A and B, and B and C. We have to find the potential difference between them. So to find the potential difference between them, what I can do is I can calculate how much charge is being stored between the capacitors that are between these 2 points, and then multiply the net capacitance of the capacitors that are between these 2 points to find the potential difference. So to begin with, I need to find out the total charge on this that will be stored in this arrangement. So for that, I will start by finding out the net capacitance of the circuit. So these 2 capacitors of 3 microfarad, they are in parallel, which means their capacitance C1 will be simply 3 plus 3 is equal to 6 microfarad. Similarly, these 2 capacitors of 1 microfarad are also in series. That means their net capacitance will also be 1 plus 1 is equal to 2 microfarad. Now, this arrangement of these 3 microfarad capacitors and these 1 microfarad capacitors, they both are in series with each other. So that means their capacitance C3 will be equal to C1 C2 upon C1 plus C2, which is equal to 12 upon 8, which is equal to 3 by 2 microfarad. And this entire arrangement, this entire upper branch of 3 microfarad and 1 microfarad capacitors is in parallel with this capacitor of 1 microfarad, which means the net capacitance C net becomes C3 plus 1 microfarad is equal to 3 by 2 plus 1 equals to 5 by 2 microfarad. So the net capacitance of the circuit is 5 by 2 microfarad. Now we know that C is equal to Q by V, which means Q net in the circuit is equal to net capacitance of the circuit multiplied the voltage applied. C net we just figured out is 5 by 2 microfarad, that is 5 by 2 into 10 raised to the power minus 6 farad, multiplied by the potential difference, which is given as 100 volts. So multiplied by 100, that gives us 250 into 10 raised to the power minus 6 coulomb, which means 250 microcoulombs. So the net charge in the circuit is 250 microcoulombs. Now, let's draw the circuit once again, or rather, let's look at the circuit once again. So in this circuit, as we did earlier, or as we discussed earlier when we were calculating the net capacitance, this branch is in parallel with this branch. I can show this clearly if I redraw this circuit in a different manner. So this is the capacitor of 1 microfarad, and these are the capacitors of 3 microfarad each. This is point B. These are the capacitors of 1 microfarad each, and they are connected like this. This is point A, this is point C. So as we can see, this entire branch, or this capacitor of 1 microfarad, is in parallel with this entire branch, which means this net charge will be distributed amongst these 2 branches equally, So that means if the charge in the upper branch is Q1 and the charge in the lower branch is Q2, then Q1 should be equal to the capacitance of the upper branch, which will be C3. So C3, and since these two branches are in parallel, the potential difference will still remain the same, that is equivalent to the potential difference due to the battery, so 100 volts, which means Q1 is equal to 3 by 2 into 100, which is equal to 150 microcoulomb. Now, since this arrangement or this setup of two parallel capacitors and this setup of two parallel capacitors, they both are in series, so the charge Q1 will be equal in both of them. That means the charge in this setup, which has a capacitance of C1 is equal to 6 microfarad, C1, and this is C2. So the charge in C1 will be equal to Q1 because C1 and C2 both are in series and Q1 is the charge that is flowing through this branch. So the potential difference between A and B, since between this point A and between this junction there is no other electronic device, so I can move this point A right to the junction. So the potential difference between A and B will be equivalent to the potential difference of this setup of capacitors or this arrangement of capacitors. So the potential difference VAB can be written as charge Q1, because charge Q1 is the charge that is flowing through this setup, divided by the capacitance, which is C1, which is equal to 150 upon C1, which was equal to 6, which is equal to 25 volts. So potential difference between AB is equal to 25 volts. Similarly, the potential difference between BC, I can move this point C right to the junction. So the potential difference between BC will be equal to VBC will be equal to the charge divided by the equivalent capacitance between them, which is C2. So Q1 is 150 microcoulomb. So 150 divided by C2, and the value of C2 we calculated as 2 microfarad. So 2 microfarad, which gives me 75 volts. VBC is equal to 75 volts.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.